Hello everyone and welcome to another video from Ishan's virtual classroom. In today's video, we will discuss equations. And this is also the first part of the series. So this is going to be actually a series. So yeah, this is the first video of it. Equations, the foundation of mathematics. Why equations are important in everyday life. So what even are equations? So let's begin off with that because maybe there's a good chance that some of you might not even know what we're talking about here. So let's just recap it anyway. So equations are mathematical statements that use an equal sign to show the equality of two expressions. So this example is 2 plus 5x plus 6y minus 6 equals 43. Algebra is entirely centered around equations. So why are equations important? Let's begin off with that. So equations are the language of science and engineering. Many mathematicians have invented equations that have shaped the world and paved the way for inventions and great discoveries. Equations can also be used to model forces and motion. Equations encourage critical thinking and problem solving. With equations, the answer to solve the equation isn't always seen right away. And it might take a little bit of problem solving and critical thinking to test out different numbers and try different numbers and operations to solve the equation. This builds our skills greatly. Equations are used for lots of different purposes in life. We are constantly using equations and usually we don't even know about it. Examples are in budgeting and finance, in charts and graphs when tracking rates, cooking recipes, and much more. Okay. So now let's get into examples of jobs that can require equations. First of all, construction. There are many jobs and tasks related to construction that require geometry, which in most cases would have something to do with equations. An example of this is when you measure how much fence you must put around your backyard. You'd have to use perimeter, and that would mean adding up all sides of your property that you will fence, which requires operations and therefore equations. Economics and finance. Equations are used for calculating interest rates, investment growth, and economic forecasting. Technology. Equations are used for developing algorithms for computer programming, encryption, and data analysis. Medicine. Equations are used for medical imaging, drug dosage calculations, and modeling disease spread. Cooking. Equations are used here for figuring out how much of something you should put in a recipe. Okay. So now, let's ask, why should students learn and master equations? First of all, it's important for students to study equations because equations are used everywhere. And as mentioned previously, in school, usually you'll be required to do activities and studies with science, technology, engineering, and math, which you can say in a short form as STEM. And with these studies, you'll have to apply these studies and your knowledge to be successful in the jobs you do, as implied earlier. In general, equations are basically the foundation of math. Understanding equations empowers and gives confidence to students that solve problems in real life and make informed decisions. An example of this is possibly even shopping. You might find a product at the grocery store, but you may find the same product that sells more of it for a higher price. You'll probably use equations to find out which deal is better so you can save money. Now let's get into our conclusion. In summary, equations are much more than just numbers, operations, symbols, and equal signs. They are the key to understanding and shaping the world around us. Always practice to get better and build yourself up until you've successfully established mastery in your goal. Remember that this is a journey toward greater knowledge and opportunity. And with that, now let's move on to our activity. So we have two activities here, but the first one, we're going to solve this equation right here. So let's look at the problem. Janet walked a total of 17 kilometers in February. For the first 3 weeks, she walked the same number of kilometers per week. However, in the fourth week, she walked 5 kilometers. How many kilometers did Janet walk in each of the first 3 weeks? So let's look at our equation. So let's use the variable d to represent the distance Janet walked in kilometers for each of the first 3 weeks. So 3 times d, or 3d, represents the total number of kilometers Janet walked in the first 3 weeks. And also, when you see 3d, as many of you probably would know, you don't always have to use a multiplication sign. Multiplying a number by a variable, you can just use the number and then the variable right after it. And, okay, so let's continue. She walked 5 kilometers in the 4th week for a total of 17 kilometers. Therefore, our equation must be 3d plus 5 equals 17. To find out the value of d, we need to solve this equation. So, we're going to look at a method to solve this. So, we're going to look at how to solve it by the systematic trial method. So, how this works is all we're going to do is just plug in any numbers that we think could work and keep trying them until we solve the equation. This equation is relatively simple, but in more complex equations that we may not be able to solve right away, it might be a useful method. Always make educational guesses that you really think could work, as it would save you much more time. Use your previous guesses to adjust your next guess to get closer to solving the equation. Okay, so with that, let's move on to our sheet, and now I'm actually going to solve this. So I have created a formula here. We'll put a number into the guess of d, and then it will be plugged into this equation, and it will give us a value. Then this will check it and see if we are correct or not. So we can do anything with the guess of d. So we can do whatever we want. We can put in 1, but that doesn't work. So that gives us 8. So really, you don't do anything like 1 because that's just ridiculous. But try to make educational guesses. That's the point. So, for example, let's try a number like 6. So, as we can see, we need to try to get 17. But we got 23 here. So that means that we need something less because 6 is too high. So we can go down like a lot. We can go down to 2. Let's try that. This gives us 11. Since 11 is less than 17, we need something more. So we could try 3. And we know that this would not work because we get 14 here. We don't get 17. And you can also see that here. It says no, so it won't work. So now we can also try 5. And we get 20. That's higher than 17, but we're pretty close. All we need to do is just go a little bit lower. And since 2 and 3 don't work, let's go down to 4. And oh, it works. Look, it says as well. So 3 times 4 plus 5 equals 17. So that's why this works. And that's why 4 is equal to d. So yeah, we solved it right there. Now let's go back to our PowerPoint. Simplifying the equation and substituting the variable. So this is common to do where we just kind of like break down the equation. So yeah, I'm going to break it down right here. So first we got equals 3d plus 5 since that's what we're supposed to do. Then we're going to do, since we're going to substitute d with 4, we're going to do 3 times 4 plus 5. And then we're going to solve what's in 3 times 4 because that's in brackets. Whatever is in brackets, we always have to do first. So that's why when we do 3 times 4, we have to solve that first. And we get 12 plus 5. So now we can solve 12 plus 5, and that gives us 17. So yeah, it's just a simple breakdown that most people do, just to kind of like help us understand what we're going to do with the equation. So as you can see right here. Okay, now let's move on to our second activity. So our problem is a little bit more modified, and it's also a bit harder, but nonetheless, it's kind of like the same idea. So Janet walked a total of 24 kilometers in March. She walked a few kilometers in the first week, and then walked 2 extra kilometers more than the previous week for the next 2 weeks. In the 4th week, she walked 6 kilometers. How many kilometers did Janet walk in the first week? So for our equation, we're going to again use the variable d to represent the distance Janet walked in kilometers for the first week. Our formula will now be d plus d2 plus d4 plus 6 equals 24. So most of us understand equations, but if you don't, if you find this a little bit confusing, let me break it down. So we're going to represent the first week by D, so that's why that's here. Then we're going to add it to D plus 2. We're going to put that in brackets so that it will tell whoever's solving it, solve whatever is in these brackets first. So yeah, we have D plus 2 because in the second week, she walked 2 extra kilometers than she did in the first week. So that's why we put D plus 2 in there. And then for the third week, she walked 4 more kilometers than she did in the first one because she walked 2 extra in the second, and then 2 extra again in the third. So that's why we have D plus 4 here. Then we also have plus 6 because that's the fourth week. And then we have 24 because that's what it all equals to. So now we are going to have to solve this, and we're going to have to find out how many kilometers did she walk in the first week. So basically, we're going to be solving for D. And we're going to use the same method. So yeah, let's go to our spreadsheet to try to solve this. So I've created another formula where it will take the number we put in for the guess of D, and then it will basically just follow the equation, literally. So it will do D plus 2 plus D plus 4 plus 6. Okay, so again, and then it's going to reflect on this, it's going to check it and see if it's 24. So yeah, we can put whatever we want in D, and we're going to have to try to guess it. So let's try something. We can try whatever we want. So let's try like a big number like 9. Don't do this actually because using common sense you probably would know that 9 is too big. But we're just doing it just to show you that you can play around with this, but just try to make educational guesses. So we can put in 9, but that's too big, and that's like 15 off. So yeah, this will not work because it's 39. So again, as I said, make educational guesses, and then use your previous guesses to adjust your next guess so that it makes more sense, and you'll get closer to solving the equation. So we could try, let's say, 6. And that gives us 30, so we're still off, but we're a bit close. So let's try to go down to 2. And again, now we're a bit far because we're at 18, so we need to go a bit higher. So let's try 3. And again, we're at 21, so we need to go a bit closer. If we try 5, we'll be at 27, so we need to go down because 27 is higher than 24. And then we'll go to 4. And look. So we have solved it. D does equal 4, and even this is saying that it works. So even if you plug it in, 4 plus 4 plus 2, which is 6, so 4 plus 6, plus 4 plus 4, which is 8, plus 6, will equal 24. So that's why this works. So let's go back to our PowerPoint right here. And now let's break down the equation for you. So again, we got D plus 2 plus D plus 4 plus 6. And now we're going to simplify this. So we're going to substitute D for 4. So we're just going to say 4 plus 2 plus 4 plus 4 plus 6. Then we're going to say 4 plus 6 plus 8 plus 6 because 4 plus 2 is 6, and then 4 plus 4 is 8. And then we have the 4 and 6 right away, so yeah. And then we're going to add all this up. That gives us 24. Okay, so yeah, we have solved this equation, and yeah, I think I'm going to wrap it up here. This is relatively simple, and I think this is a great method for people, especially who are starting out, because it's a very simple one. It's basically, it's like a very simple idea. All you have to do is just plug in, it's just substitute a number for the variables, make educated guesses. So yeah, I think this is a great method to show you guys, and this is part 1 of the series. So next episode, we're going to be looking at a different method to solve the equation. It's relatively simple as well, so it's also going to be good. That's why I like equations, and that's why equations does connect to critical thinking, because there are multiple ways that you can solve these equations. So that's why I love equations, and that's why I love teaching about these. So, if you have any questions, leave them in the comments below. I'd love to hear them, and I'd love to answer. And yeah, see you in the next video.